Welcome pre-calculus students to another video lesson. The first thing I want to do is start out with a shout out to Molly Conroy and Jack Jacobs. This is coming from a competition that happened the last time I made a video. They were the first ones to win, so they get a shout out during the video. Also a specific not mention of the student who shall not be named. So what we're going to be looking at is what happens when we add, subtract, multiply, divide functions. The first is sums and difference of functions. For functions f and g that have domains p and q, the sum and differences are defined by. We're taking f plus g inside parentheses. It's really just f of x plus g of x. And the domain is the intersection of the domain of p and the intersection with q. Another way of saying it is that just all the elements that are in p that also are in the elements of q, that's what our domain is. It's where they cross. F minus g of x is the same thing, except for subtracting. F of x minus g of x. And the domain is once again the intersection of all the elements of the domain of f of x with all the elements of the domain g of x or p intersection q. Products and quotients work pretty much the same, except for we're going to have f of x times g of x. Domain, once again, the intersection of p and q. The only one that's going to have a different domain is when we're looking at the quotient where we're dividing. This is f of x divided by g of x. But the domain is going to be, once again, the intersection of p and q. But we have one tiny little exclusion. G of x cannot equal 0. Obviously, because then we're trying to divide by 0. That doesn't go over too well when you're following the rules of algebra. Some examples. The domain given f of x equals 2x plus 1. G of x equals x squared plus 2x minus 1. And h of x is f of x minus g of x. We're trying to find a couple things. First of all, the domain of h of x. The domain of h of x is going to be the domain, the intersection of the domain of f of x and the intersection of the domain of g of x. The domain of f of x is going to be all real numbers because we have we're not trying to take the square root of anything. We're not dividing by anything. So we can input all real numbers for f of x. We can also input all real numbers for g of x. Because we can input all real numbers for f of x, we can input all real numbers for g of x. The domain for h of x is all real numbers. When we evaluate h of 3 using the definition, so h of 3 is going to equal f of 3 minus g of 3. We're going to plug in 3 into our f of x, so this is 2 times 3 plus 1, this 3 getting plugged into this x right here, minus g of 3. G of 3 is 3 squared plus 2 times 3 minus 1. After some basic computations comes 2 times 3 is 6, plus 1 is 7, minus 3 squared is 9, plus 6 minus 1 gives you, what is that, 15, 14. So 7 minus 14 gives us final solution of negative 7. Which means h of 3 equals negative 7. To find a new function rule for h, what that's saying is take h, if h of x equals f of x minus g of x, we can just plug in the actual x values. 2x plus 1 minus x squared. When I distribute that negative, it becomes minus 2x plus 1. And we can combine like terms. It becomes negative x squared. The 2x and the minus 2x cancel. We're left with plus 1 gives us 2. So h of x, we can say, is the same thing as taking negative x squared, adding 2 to it. So use the new rule to evaluate h of 3. So we're going to say h of 3 is going to equal, plugging this 3 into our new rule, it will equal the opposite of 3 squared plus 2. Sorry, my pen's not working here. Give me a second. Okay, now that my pen's working again, this is going to be the opposite of negative 3 squared plus 2. This gives us negative 9 plus 2, which once again equals negative 7. So we can see by using the definition or by using a new function rule, in other words, turning h of x in terms of x, we get the same solution. The same process is going to work when we define rules being multiplication. To let you know, this h of x equals f times g of x is the same thing as h of x equals f of x times g of x. Now, the domain of f of x is all real numbers. The domain for g of x is going to be x minus 5 has to be greater than or equal to 0, so x has to be greater than 5. Now, the intersection between all real numbers and where x is greater than 5 is x is greater than 5, which means our domain for h of x is x is greater than 5. Next thing it says is find a new function rule for h of x. Well, once again, h of x equals f of x times g of x. So we can say h of x equals f of x 3x times g of x, the square root of x minus 5. Nothing special happens here. We can't cancel. We can't combine any like terms. So that is our h of x rule. When we evaluate h of 3, we're going to be plugging 3 into our new rule. 3 times 3 times the square root of 3 minus... Oh, I fell for it. Look, our domain is